Hello, everybody. My name is Brinley, and today I'm going to be talking about the James Webb Telescope. So, to really understand telescopes, we need to know the three main types. There's the cardiopetric, the refractor, and the reflector. Oftentimes, most telescopes that go into space are going to be a cardiopetric, just because a cardiopetric is more of a photographic telescope rather than an observation telescope. And so most things in space, because we can't physically look through them ourselves, they're going to be a cardiopetric that takes pictures and sends them back to Earth. However, a James Webb is going to be both cardiopetric and a reflector because it uses both mirrors and cameras. So just a little bit about the James Webb. It is currently the newest telescope that we have in space. It was launched on December 25th of 2021, so it makes it less than a year old. And it is currently the largest and most powerful telescope to have ever existed as of right now. As you can see in the photos to the right, those are some of the mirrors that are on the telescope. You can see just in comparison how each individual mirror is very big compared to all the workers working on this telescope. These two photos are actually from NASA themselves. So there are many elements to the Webb, but the three main parts to it is the infrared camera, the hat, and mirrors. The infrared camera, as you can see, display shown in the bottom right. It's also used by firefighters a lot. It's a very common type of camera for stuff like this. And this picture actually is a really good example of how it works. You can see there's a lot of dust clouds in space, which kind of shows what the picture on the left represents is like the dust. It's really hard to see through them. But once you use the infrared camera to take a picture or a video, whatever you're trying to use it for, you can see how the colors and the heat of things come through. And this is really beneficial for using it for space, because when it comes to dust clouds and you're trying to find galaxies, galaxies are going to be a lot hotter because of the gas or stars that may be contained in them. And those balls of gas that are heated are going to stand out against the cold dust particles, which is a good example here. As you can see, like a hot person hiding in this this smoke. You can see how we can see them with the camera, but not without, and that will come in handy with stars or other galaxies we're trying to find. There's also a part called the hat. It's a component on top of the telescope that shields away light and heat. Light and heat is not good for cameras, especially an infrared camera, because it'll mess with the camera's sensors to detect other pieces of heat, and we are trying to preserve the quality of each image for as long as we can, so we can hopefully use this telescope for as long as we possibly can and have it be a reliable information. There's also mirrors, as we showed in the previous slide. Those gold mirrors are used to keep the quality of the image up to what we need it to be. In order to accurately determine information, we would like the photographs to be as accurate as possible, as well as the image making the image as large as we possibly can. Because we don't get those photographs back often, we want those photographs to be big enough to where we can get as much information from each photograph as much as we can. And then, of course, the purpose of the Webb. The purpose of the James Webb Telescope is to find possible life on other planets. It's also used to observe other galaxies or new galaxies that are very far away from us from Earth. And, of course, the exciting part that everyone loves to see is the images that is captured in space from a very large distance from Earth, and that is sent back to us to view and analyze. Like I said, those pictures are sent back to us, and this is actually the first image that is ever sent back to us from the James Webb Telescope. But since then, there have been thousands and thousands of photos. In this photo specifically, there's just thousands of galaxies, which is where those mirrors come into play. They help the image be larger. So instead of just seeing a couple thousand, we see a greater amount in one image. And then, of course, the James Webb was actually designed after the Hubble telescope. It was designed because we knew that the Hubble telescope wasn't going to last very long. I think it lasted up to 15 years. And so we knew eventually we were going to have a telescope go in and take its place and give us new and updated information. And so in doing so, they sent a new telescope out there that would have updated information, new technology, things that would just do things a little bit better than the Hubble did. They were designed for the same job, so in many ways they are very similar. However, there are minor details that are different. As you can see here, the two are very different shaped. This one down here is going to be the James Webb, and this one up here is the Hubble. The Hubble is more of a silicone shaped, as the Webb is more coned. That is due to the way it was launched in. The Hubble was just launched in as the cylinder size as it is. The Webb was launched in folded, and once it got into space, it unfolded, which is the reason why it is shaped that way. Another big difference is the mirrors. They're different colors and different sizes. The Webb is just overall a bigger telescope, which helps it do its job more efficiently and clearly. And then, of course, how it works. We kind of went over this. The infrared light, we can't see it with our human eye. So in order to get through all those dust particles, we use the camera to pick up on those very hard to see pieces of heat. And then over here is a really good photo that shows the other elements of it. So this is the flap, kind of goes into how it kind of maneuvers. The antenna, which sends the photos back to Earth. The sun shield, like we had said before, kind of helps with that. This helps deter the heat as well as any light that comes through, which protects the camera down here. And this is the top view. This is where the mirrors are. This helps reflect light back into it, or as a reflection to show other surrounding areas of space to the telescope. And that will be it for today. Thank you for listening to my video, and I hope it was beneficial.